me just get. Okay, so I'll give you a brief idea about what my talk is about, but just a quick introduction. So I've been at Microsoft for almost a decade, and I started in the Windows Server org, released 2 versions of Windows Small Business Server and Home Server, worked in Azure, Windows Phone, Windows 10, worked in a lot of different areas. For the last, I think, about 4 years, I've been part of this team that's trying to reimagine or reinvent how we actually engage with our customers. And for the last 2 odd years, we're actually trying to build how AI can be used for customer engagement and support. So that's my product. You can go on support.microsoft.com and on Windows 10 as well. So it's actually an app that that helps people to get more help out of Windows in a conversational AI format. We do a lot of deep learning and natural language processing, understanding and comprehension to get the right kind of support to the people. And it started pretty small, but right now it's been used by all these other partners as well, and we're obviously looking at productizing this for Microsoft. And there's a small part of it which is already live, but you can ask me later what this product is about. It's mostly called Customer Care Intelligence. What else? I am involved in a little bit of recruiting and developing PM talent, so I do talks like this at Microsoft as well, although I haven't done anything very recently. And personally, I like traveling, dabbling in music, and some wildlife photography. All right, so one more thing. So my talk's going to be about 35-40 minutes. So if you can hold off your questions, so I'll give you enough opportunity to get to your questions after that. But let's go through all of the material, and we can have an interactive session after that. So I'm going to start. So this talk is about 2 main things that I personally really care about. Obviously, product management, that's my career. That's where I strongly believe that good product managers are very crucial to success of products. But I also wanted to talk about AI, and everybody's talking about AI, things like that, and I just felt like I had some experience and I could talk about how we actually bootstrapped our product and built it, and all what we see on TV, all those looks good, but like, what does it really mean to actually go build something real for customers? But I'm going to start a little bit with introduction to machine learning and AI, just to set. I'm sure some of you already know what all this means, but I will set some context for that. Then I'm going to actually dive into how AI products are built, and you will see that most of that part is centered around what makes a good product manager, and some nuances of what it means to build AI products, because there are some differences, there are some nuances, there are some small skills you have to build so that you are in the forefront. We'll talk a lot about data and experimentation. That's another thing I'm really passionate about. And I'm finally going to end up with some questions for you guys to think about all the social sciences, because we are finally trying to getting in that age where the social sciences are becoming more and more relevant, mainly because of AI. Q&A at the end. All right, so we hear the term AI, and I was just reading through I just did a search on the news, and pretty much everything is called AI. But for this purpose, this discussion, I'm going to talk about AI that I believe, are quintessentially human. AI means artificial intelligence, humans are intelligent. We're trying to have machines do stuff that are quintessentially human. Now, there are techniques and models that are used in a variety of use cases, but I am going to talk about things such as speech, language, vision, reasoning, perception. And the perception is the one that's really fascinating, but because that's what makes us human. We understand, we can comprehend, and we can reason with people, those kind of things, right? So concepts in terms of research, it's actually not new. A lot of the research and the development of these fields actually started in the 50s. It just takes long time for technology and all the interesting things to actually catch up for it to be real. 2012 is kind of roughly known as the inflection point for AI, meaning that it started becoming more real. So I don't know if you guys know what AlexNet is, but AlexNet is a deep neural network for image recognition, and for the first time this was trained on 2 GPUs, and I'm going to talk more about that, but 2 GPUs on the ImageNet database for classifying 2,000 different types. And the reason 2012 is known as the inflection point, because a lot of the algorithms and all of these things were there. They were in the research labs, and like a lot of people are actually doing theory work. But what we got in, and there was another thing I am not showing here, but there's this absolutely exponential growth of compute power supported by publicly available data, and all of that is actually affordable. So that really democratized AI and helped pretty much everybody start building and really accelerate it, right? Now we've seen exponential growth in the last 5 years. And the reason I am really excited about this field, mainly because I believe, like the last 5 years, we've talked about the cloud and the app-based economy, and it has actually transformed a lot of industry. Like a lot of companies have become rich, a lot of value worldwide. I believe that AI is going to actually transform in things that we haven't even imagined right now, in applications and other things, mainly because it's starting to get into things which humans do. So quick, I'll cover 2 slides on what machine learning is. I'm sure most of you know. So a model, we hear that, we hear about model training, models, things like that. It's nothing but an algorithm, takes a set of inputs, also called as features, performs some basic operations like mathematical operations, additions and squares, and it could be, some of it is complicated as well. It uses a set of parameters on those features, also called as weights, and to provide some outputs, right? Very basic stuff. An algorithm takes inputs, uses some parameters, provides some outputs. And that's classic algorithms, right? Every algorithm, every API does something like that. What's different about ML is basically the parameters are learned by the algorithm itself. So we don't provide the rules for how parameters are actually done. And it's done by a process called gradient descent. I'm not going to go much into details, but the way it happens is this. You start with some basic parameters. You can pick whatever you want, but there are some rules, there are some good techniques around that also. So what you do is, and I'm talking about the classic supervised learning model. So you start with some basic parameters, you check the performance of it, of the algorithm in terms of whatever it's trying to predict, and you say that it's too far off, right? So you tweak the parameters a little bit, and you tweak it using the gradient descent method, and you guys can look up what that means. This is not a pure ML class, otherwise I would have gone into details. This is about a PM class. So you keep doing that, you keep iterating, tweak it little by little, you do it many, many times until you reach a level where you cannot improve the performance anymore. And you get a set of final parameters. When we talk about a trained ML model, it's basically the operators plus the parameters. They're together called as a model. Okay? So I'm going very fast here, so you guys can ask me questions later, because I just want to get through this and then talk about actual PM stuff. So neural nets are they were inspired by human brain. Human brain is it actually works kind of like the model I talked about. It has some inputs, synapses, and each cell does very, very simple things. It actually doesn't do a lot of stuff, but each cell does very basic operations, and it sends it to the next level. So in computer science, it has some basic units, and there is a non-linearity. Now, there is a lot of mathematics and research which talks about why the non-linearity is important. Again, I'm not going to get into that, but a basic neuron in a neural net actually consists of this: some additions and a non-linearity. And this is the thing that allows you to do highly complex tasks at a massive scale. So the most common types are called as feed-forward networks. What basically does is each output of the neuron is fed to the next. It doesn't have to be, but those are one of the more common ones. It can feed onto itself as well and take branches, things like that. It's also easier to understand some methods like backpropagation and things like that for feed-forward networks. So using these simple building blocks, we can start building a network. So you can start layering them vertically. It's actually called a layer of a neural network. You can keep adding layers, okay? And you can start connecting them, right? And you can keep doing this. In this case, I have the same number of neurons per layer. It doesn't have to be. It can be different numbers. It can be more, equal, greater than, etc., etc. This can actually go into another, basic ML model or some classifier, things like that. But that's the idea of what a neural network is. And so intuitively, what it's doing is, if you think about each of them are logic gates. It does either output 0 or 1 or maybe something in between. But because it can go through all of these different things, it can actually create allow this to make pretty complicated decisions which cannot be done through linear mathematical models. Okay. Again, they trained through backpropagation. The reasons I put these names is that, you know, when you actually take classes or, you know, ML classes or actually talk to the researchers or the scientists, you'll hear these words and things like that. So it's just good to know as a PM. It's good to know some of the lingo as well. Okay, what's deep learning? Deep learning is a very nice branding. And it sounds cool, it's very deep, but basically it's massive neural nets, right? And you can have, and you know, I talked about those parameters and those weights, right? Because it's so massive, it can, a neural net, a deep learning model these days have millions of parameters. So, and you can see why, right? Each of these links which is going through is actually has a weight, and all of those weights can be trained and fine-tuned and things like that. This is my diagram here is very basic. It's a block diagram, but layers can combine various ways. They can go back, they can go up, and they don't have to be fully connected. Oh, I think I forgot to say, like in the previous slide, every input was connected to the output. That's also called as a fully connected network, but it doesn't have to be. Not always. It doesn't always connect to the whole thing. And because it's so complicated, and it needs to train like billions of parameters or tweak. So basically what, the process is same. You're tweaking parameters little by little until you get the output. And it needs to tweak millions of parameters which are effectively interacting with each other. So it takes massive amount of compute and data to actually train. And this is primarily, I talked about that before, this is primarily the reason why AI is a reality now, because we have compute and we have GPUs. You can just sign up and on Azure, AWS, GCP, it's not very expensive. You can train your own model that you can actually build, and a lot of platforms are available that allows you to build some of these models just through visual tools. And because of that, they can actually perform highly complex tasks. Okay. Different types of models. So I'm talking about the most common ones. So convolution neural networks, also known as CNNs, they are primarily used where the input data has spatial information. So vision is a classic, but that's, a lot of other things can have spatial information and or multidimensional information. So convolutions are basically filters. So what you do is you take images through a set of filters and the neural nets, and it tries to learn things like edges and the nose and things like that. Eventually it figures out that what's showing there is a dog versus cat, things like that. Okay. Recurrent neural networks are anything that needs a sequence. Speech is very common because our sounds are over time period, and each word after language understanding, it needs it to have the sequence. I call it temporal, but anything that needs a sequence is usually used, like RNNs are used. You can have combinations. These days, there are these models that do scene description, which is like your, sports commentary. That would be cool if, Alexa or Siri was able to do that. But that's science fiction. But that's what it's doing visual stuff, but it's also doing time sequence. Somebody's running, catching the ball, things like that. But but you can see that some of these are actually being combined And obviously things like self-driving cars and things, those a lot of those kind of technologies are used there. GANs are very fascinating. So what you do is you take two networks and make them fight against each other. So one network, so I don't know if you guys have seen what deepfake is. Just do a search. Just go back and search for deepfake Obama. So one network tries to mimic Obama, his voice, his, and the other network tries to determine if it's fake or not. And they fight it. There's no additional data that's coming. So one network says, yeah, I'm Obama, and the other network says, no, you're not. And they keep improving each other, so they're adversarial. And that helps it to get to a level where you cannot tell the difference. You should see the videos. It's very scary, creepy at the same time, but that's one of the techniques that is actually used. Okay, transfer learning. These are this is getting used quite a lot. It's also a technique where you take a fully trained model and try to add other stuff on top of it to do more stuff, so you don't have to train it from the start, because training is actually a very expensive process. And then there are other methods like reinforcement and online learning, where you actually just start from zero. But because there's so much data coming, you can actually train it on the go. Again, it's these itself. Each point itself is probably a full day of talk. I just wanted to let you know it is worthwhile to go read about these. There are lots of courses, fascinating space, and I've been reading about this. I've been taking some of these courses myself, because I didn't know about any AI stuff until 3 years ago. All right, so we talked about AI quite a bit, and so we're gonna switch to the core of this presentation, which is what does it mean to actually build products. And what you will see is that most of this talk is actually about product management. So if you've done other speakers have come, so you'll see quite a lot of commonality. But I also talk a lot about how we did stuff and what are the differences, things like that. And some of it I've learned over the years, some of it's my own philosophy. So we'll see if that philosophy holds over time, but that's where I'm. So products that are viable and valuable. And PMs typically live in these three-pronged. I don't want to call it tension, but to figure the trade-offs and balance all this, like the technology requirements, the business requirements, and the customer requirements. So all right. So no, I heard something. So they're rooted in fundamentals, right? Like just a recap. Solves a real customer need. I've seen so many products that don't do that. It just sounds cool. You take some technology and it sounds like the technology is cool. You try to find a problem, and you have to, and this is what product managers do, because you look at customers, what their problems is, what is an unmet demand in the industry, or somewhere. It could be a very small thing, or it could be something really large, but it has to add value, right? Maybe you can fool some VCs for a while, but eventually it collapses, right? Provided business value and is actually technically feasible. How many people know about Microsoft Bob? Microsoft Bob. It's fine. So Microsoft Bob was an experience built into Windows 95, which was a virtual room inside to help people discover Windows. It had a lot of AI concepts, a lot of personality, those kind of concepts, things like that. If you read about it, it's actually very futuristic. Wasn't technically feasible on Windows 95, but and Microsoft has other, and every company has things like that which looked really good, solved a, but it has to be technically feasible. It has to be realistic, and have products and I talk from my Microsoft background. There are startups, but I think it holds true. You have to have some long-term strategy. Like if it's a new product, obviously it needs to solve the business need, but even if it's not, have to think about what the competitive advantage is, because in this day and age where, and we're talking mostly about software products, it's not hard for competitors to come and catch up, right? Well positioned and aligned with the ecosystem. So this applies a little more to bigger companies. If you're a startup with a single product, you probably don't have an ecosystem. But eventually, bigger companies like Amazon, Microsoft, Google, once you grow to a certain, you have to find other areas of growth, and it has to be aligned. And the main reason again is aligning with the ecosystem itself is a competitive advantage because it feeds off each other. Obviously has growth potential, right? Finally, well executed. We're going to talk a little bit about execution and how do you go about building that. But PMs, especially on the engineering side, they drive the vision and strategy. They are called different things depending on where your company is. In startups, they are usually the founders. In bigger companies, they drive, it always starts with some ideas about what the product should be, but they are the ones who actually materialize it into something that's realistic and that can be released. And this is true about the discipline, right? A lot of, like when I started at Microsoft, I did this for one button. Right, like okay, there's no strategy for a button, but as you grow, the idea of like whatever the scope of your influence is, the PMs actually drive and build that. And along the way, is another thing. PMs don't have engineering reports. You may have heard the idea of PMs being the CEO of whatever they're owning. I call, not true, because CEOs actually have authority and decision authority. So whatever you do, like all of these, you need to influence and get people on board. Lower levels, when you're starting out, smaller scope, you have to influence your team. But this concept, like, I have to go influence a lot of partners, and I talked about the product where Windows, Xbox, Skype, all these partners at Microsoft are actually using our product. We have to influence them to actually adopt, and also engineering teams and the business and all of that, right? It's talked about a little bit about the customer. How are we doing on time? Good? All right. It starts with the customer. And the way I want to think is there is a need. Forget about this. That's where the magic's going to happen. But something happens and they're a happy customer. For at least a moment, or for at least in this phase, forget about implementation. a lot of times I've seen it the other way around happens, where we already have an idea of implementation and we're already thinking about what the customer need is and how we're going to implement it and how to make. This is actually a very useful way I have found it, and I try to keep reminding people, forget about implementation, we'll come back, let's start with the ideal situation, and we'll come back and make trade-offs once we get to the implementation. And that's a much better way, in my opinion, than starting the other way around, because here you can push your engineering team and you can push them to actually do things which are maybe not possible right now. I also call it establishing your North Star. You have to know where you're going. So for instance, in my product and very similar products, our North Star is in X amount of time, years, whatever, my chatbot will be indistinguishable from a real customer engagement representative. And that's your North Star. It may be a long way there. I mean, Google did an awesome presentation. I don't know if you guys saw in the last, where the assistant was making a call, reservations and things like that. That was believable. But doing it on the other side, because we do a lot of support and those kind of scenarios, it's but that's a North Star, right? And talked about this. Build compelling user stories and scenarios, and nowhere in these should any technology or implementation or how you're going to do it should come. Now we may have during discussions and during investigation of if it's possible or not, we may tweak it, but as far as possible, try not to have technology as part of the user stories. And finally, all products have customers. I build API platforms, I build consumer products. All products, somebody's using it, otherwise it's not a product or it's not valuable. Somebody has to use it. It's really important to understand them, and again, goes back to the customer need. I do a lot of photography, and I always say this, like, if you're the developer in Lightroom doesn't need to know what photographers are and what they go through every day, but the product manager does, and they're the ones who are driving all the requirements, and they're driving what that product should be, because ultimately the product is for photographers and they need to understand deeply. And hopefully some of those product managers are photographers themselves. Okay. PMs put customers first. I think we talked about. From your North Star to your next steps, and I put this in a 2x2. I also use my company logo, like shameless, selling. But I like 2x2s because it just simplifies stuff. In a real case, this might be broken down, but simple as that. Like on the vertical scale, it's customer value. Like high means like it really adds a lot of value, and customer value could be both customer and business value. And on the horizontal scale, it's cost and complexity. And roughly, like, let's say brainstorming, you have ideas, you have user scenarios, user stories, things like that. You can start throwing them in these buckets. You can have more complex buckets, but right at the beginning, it actually helps to have simple buckets. That's no-brainers, because it's cost is low and provides a lot of business value. You should do it. Just do it. I mean, there's no point thinking. Typically, these are the ones that, what you're building. So you start with that because that's going to take time and a lot of complexity. Maybe it's not proven yet, things like that. Low-hanging fruits, I think, again, this one is the one we always debate about in our groups, like, is it really worth doing? What is it taking from us? But if you really have low-hanging fruits, which maybe doesn't add a lot of value, but it's so cheap that it's worth doing, they're nice to have, you might as well do it. In the beginning, just forget about these ones. And this, the last one, it's not worth it. And I am often surprised how many times we don't have this discussion, and how many times also what ends up happening is you land up in a project in the middle of it, and it's awkward to ask this question, like, is it adding value? But you should always ask this question and try to figure out if there is customer value, and try to take these out. It's actually not even worth keeping it in your backlog, because you're never going to do it. You're going to be in this most of your time. So this kind of framework allows you to actually establish what we call as a minimum viable product. You can also use other data points to get to that customer value, etc. Market research, Kano study. Does everybody know what a Kano study is? Then I'll take 1 minute. So Kano study asks basic 2 questions. How unhappy will you be if I took out this feature? And how happy will you be if I added this feature? So it kind of gives you the answer to must-haves and delighters, things like that. So for instance, if I said, you know what, let's say I was an email application, right? I'm not going to give you CC, like the carbon copy. People are going to be really, because but if I said, okay, I'm going to give you carbon copy, like the CC, BCC field, they're not going to be very, they're not going to be delighted with it, because it's basics. Every email product should have it. But it helps answer those questions. And like big companies like Microsoft, and we actually fund Kano studies, like where we don't have a lot of good idea about a product, and we also maybe have competitors who are already there, and we're really struggling to catch up and actually prioritize which one we should build. Right? Little cost complexity, especially a big product, can be obviously technology, dependencies, resources, and timelines. I also want to touch a little bit on that, but this is a discussion in itself, like how do you balance building user scenarios versus actually engineering investments. And it kind of goes, to me, the engineering investment kind of goes in here, because a lot of these engineering improvements actually helps you eventually, because it allows you to deliver things faster, innovate faster, things like that. But again, if you see it from a lens that eventually it's going to be helpful for customers, it really helps prioritize which engineering investments you're going to make. And question like if somebody comes with the latest technology, we must implement React, and like okay, we'll think about it, but there has to be some real value. There are some investments I'm going to talk about, which in our product we've found to be super useful. So again, PMs drive prioritization, but obviously it's, as I said, it's a lot of influencing. You talk to a lot of people and get them to align with it. So building out your solution, and I'm going to start talking a little bit about AI as we go on. Start simple. Take a few use cases in those 2 buckets I showed, and do them really well. A lot of times uh, what's called as a feature creep, where you keep adding stuff. Just say no and just build one small scenario. It does very well. Okay. This is the place where I start getting into the AI, and again in that mode, start simple. Even if the product is very AI focused, if you're building like a speech or vision, or build a reasonable experience without AI. You will need it. It is a probabilistic model. You are not going to get 100%. Our product, for instance, we are doing most of the research in English, and not only English, EN/US. And so I had to go build it for the rest of the 110 languages Microsoft actually supports. And it has to be reasonable, it has to work, and anytime AI is going to fail, you have to build it. So do not forget this. And we often do this as a fallback where, okay, what happens? I personally think that start with this and then improve on top of this by adding AI and how it can add value. This kind of depends, but a lot of this experience I'm talking about, it is actually going into the mode where you're trying to do stuff that humans do, and you have to ask that how would a normal person do it. So just to give you an example, so we have this conversation almost every day. We're a chatbot. It does stuff. It gives you refunds. It helps solve problems on your PC, things like that. Now, old concept of UX or UI development, wizard-based approaches, those kind of things. Humans don't do that. When you ask human a question, they don't give you search results. They give you like, here's the answer, here's the other answer, or I don't know, right? So you really so I keep so the way I've built a lot of the UX and a lot of the things I've built is like, hey, can you sit with me and let's just talk through how this is going to work. But that it was completely different when I was not doing AI stuff, because I could just talk through, okay, the user has come to this page or this experience, they need to finish a set of tasks. What is the easiest way to get that done? And that will be designed much more differently than if you were actually sitting with a person and getting that done with them. Iterate, learn, improve. Your product will get obsolete, or your a competitor will catch up eventually, so you got to keep doing again and again and keep improving throughout. And throughout the process, obviously PMs do a lot of execution. It depends on the companies as well, but PMs do define the roadmap and the timelines, what order. If they're not doing project management on a day-to-day basis, they definitely try to unblock or make those decisions on an ongoing basis. So now you have user stories, you have some idea, you have built your thing without AI. Does AI apply? And here are some questions to ask. Are there patterns, right? So you can never build. You can build the most complex model. You can never predict the coin toss of a fair coin. There is no pattern. But the next question to ask. And sometimes it's obvious there are patterns, sometimes it's not obvious. There are actually statistical tools to go and also do some exploratory investigation to see if there are patterns. And sometimes I've done stuff where we tried to investigate something and we saw there are no patterns and it was not worth going for it. Would an expert be able to predict outcomes? A human expert? And not just anybody, and I call it out that it has to be an expert. Just to give you an example, if a doctor is given all the test results and the symptoms and things like that, a good doctor would, with a high confidence, be able to diagnose what the problem is. And that's another question to ask. Like, in our case, we ask the question, when you actually call somebody and try to explain your problem, would that person be able to do it? If that person is not able to do it, there's no way machines are going to be able to do it. Okay, so we know that we could apply AI. Do we have enough data needed for training? This is also an area where we often miss out, because we go, any new model, if you're trying to do it, it needs to be trained, and it needs massive amount of training data. A lot of times it seems like we have patterns, experts will be able to predict outcomes, but we don't have data. So it's not, so the first thing you might do is actually go and collect data. And by the way, the best way to do that is through the reasonable experience you built without AI. And because you have a reasonable experience, you can start with the AI not doing anything, but it's still reasonable for the customers, it works, but you can keep collecting data so that you have enough data, and then bootstrap to actually go train your model and start providing. Deep learning, I don't know if you guys can see this. It doesn't matter. There's a lot of lot of jargon here, but different types of models. This is where deep learning and these models are, and at this end is rules-based. Rules-based is basically if then else case statements, right? If this, do that, else do that. And then there is all these machine learning based models, and then it goes to deep learning. It's quite obvious what these are, and if Brian's going to share it, you guys can probably read it better. You should also look at this statistical inference one, because it actually is mostly not complex, but it sometimes gives you pretty good results. Often actually okay to start with rules-based approaches. Again, goes back to applying that to your experience without the AI. It gives baselines, it can collect data, and it actually helps you get a product up and otherwise you may be just training the model forever, trying to figure out how AI works and things like that, and never get it out of the world. So it's actually okay to start with rules-based approaches. And in our product, we do this a lot, like in combination. It may not be obvious, but under the hoods, we actually do stuff like this quite a lot, which are purely rules-based versus where we actually try to understand the natural language and things like that. Okay. You can also, I actually suggest that there's so many frameworks and things available right now. Just use them before investing in building a model of your own. These are easy. They may not give you the exact needs, but they'll help you prototype and actually validate some of your basics. And again, this slide is mostly about, as a PM, driving some AI technology or whatever technology you are, you don't need to be a coder, you don't need to be writing algorithms or research, but you do need enough understanding of the core and technology to have meaningful conversations and set goals for your team and for your design. So the possibilities and limitations of technology. It's really, really critical. All right. Let's talk about data and experimentation. It's one of my favorite topics, and you can't manage what you can't measure. Anyway, so KPIs, key performance indicators, right? We have spent a lot of time figuring out what KPIs are, what our key KPIs are. They are based on customer and business goals, absolutely have to be. Lot of companies, I've heard the number being thrown, which is number of users, not the most useful, like you can sign up users. It has to be active users and things like that, right? Simple, measurable, sensitive. What does simple mean? Let's take an example. Microsoft stock price. It's simple. It's very easy to understand what it is, stock, whatever the price today was. Is it measurable? Absolutely, it's measurable. Is it sensitive? And the reason for that is, can my product move Microsoft stock? Probably can. I believe it can, but I think Satya's speeches do a lot more than my product. So you have to find something that's sensitive, right? You can measure and actually make decisions on, right? So we use something very simple, problem resolution rate, and how many we are actually taking to assisted support, customer satisfaction, those kind of things, which we can measure. I mean, we can't measure. Okay. So this is a. So before we go into baselines, right? It's very important to have this discussion when you're building the product. In fact, I often say that we should have this discussion before we go build stuff, because one of the first thing you might actually build, everything that you build, every feature, needs to have those KPIs built into them. And if you don't do it, they need to be part of the engineering investment. So like testing and quality and performance, KPI needs to be another item in there. And if they're not decided early enough, it's hard to get it right later. It's also hard to make decisions, right? And you can set goals using that, like especially if you have some baselines. If you don't, that's fine. You can start in collecting baselines before you set goals. And as far as possible, the goals need to be as quantifiable or as achievable as possible. Figuring out a reasonable goal is as much of art as much as science. We always try to set ourselves, higher than we can think, and if we can, because that allows us to push more. But if you do have baselines, should call out what does success look like. So when we started, we didn't have baselines. So the first thing we did was to collect baselines, and at some point we said, okay, this is what we're getting for the investment we've made so far. So we asked the question, what does success look like? Can we double it in a year? Our resolution rate. We had a discussion, and some of us thought, no, we were crazy. Some of us thought, no, that's, it's good to have those ambitious goals. We did decide on doubling, and we have, kind of quite close. But it's good to talk about that. What does success look like? Like, are you going to have more usage? Are you going to save costs? Are you going to, you will also find that during your discussions about KPIs, one KPI is going to conflict with other. Typically, here's the thing, everybody buys from Amazon, right? What will make you the happiest? Let's say they have one measurement about how much business they make, and the other one is customer satisfaction. The easiest way to make customers happy when you're selling stuff is to give it for free. It directly conflicts with your business goals of making money. So you will have KPIs which directly conflict. I want to make my customer happy by giving stuff free, but at the same time, I want enough money. So you have to have those discussions, like what trade-offs are you willing to make? Like, okay, if I give up this much, and ultimately they're based on goals, right? Okay. Again, PMs live and breathe KPIs. They talk KPIs, and like every sentence these days is punctuated with one or the other KPIs. Experiments, okay? So one of the great things about cloud-based or web-based development is actually allows us to run experiments. And experiments is actually one of the best ways to not only measure impact, but to actually make sure you're going in the right direction. So a few things, experiments are simple, right? You have something new, you measure it against what you have right now, and you see if it's doing better than what you have. So very important to do one small change at a time. If you do too many, it's really hard to actually tell which one caused what. And so we are very careful. We try like very small changes at a time, and we're very strict about how we make a decision on. They're based on a reasonable hypothesis, and again, a hypothesis as much intuition as much as though if you had time and money, you will let evolution take its course. It's going to take 10 billion years, but eventually you'll get human beings. But we don't have time, so you have to think through and that is one of the subjective discussions we have. Like, out of the 20, 30, 100 experiments, which one should we go after? And we try to make the call based on some intuition we have about customers or where we think we have to choose. So you have to have a reasonable hypothesis and discuss and break it apart and see, and then you run the experiment. You have to make sure, we talked about KPIs, what the success metrics of that is. I'm going to increase satisfaction, I'm going to increase one of those things. Guardrails, often what happens, as I talked about, one increase in one KPI can decrease. So you must also have some guardrails. And if you have already discussed what the trade-offs are, you can set that, okay, I'm not going to let that go below, right? Some of these are, well-defined. These are experimentation things, well-defined control and treatment groups, isolated random equal samples, statistically significant outcomes. I'm going a little faster because I think 15 minutes. Okay. Yeah, I think we're so almost towards the end. You guys can go and read a little bit about experimentation, but a lot of times these fail because we did not use isolated randomized equal samples, or we did not check the statistical significance of an outcome. We all there used to be this thing called as a 0.05 p-value. All it says is, you run 20 experiments, you're going to get lucky with one. 0.05 is 1 by 20. So I don't know if you guys know that, but it's a very standard industry term, means nothing. There are much better tools with p-movement and other statistical tools to actually analyze. Do not use 0.05 p-value to say that my experiment was successful. We've run about 50-60 experiments. If we used that, 3 of those experiments would have been complete luck. Avoiding gaming. this is another thing that's very easy to get into. So we ask a simple question: did we solve your problem? Yes or no. There are two ways to get that number up. You can have more yeses, or you can decrease no's. All you have to do is make it really difficult for people to click the no button, and you've got. I'm taking an extreme example, but while you have to ask that question: am I gaming it? Am I, is there something in the experience that's making the KPI to show something more than it should? Okay. And the last thing, this has been hard to do. And what I mean by data-oriented culture, that hopefully every discussion has some, like, people bring facts, data. Nobody says, I don't think it will work. They say, okay, and I've done a lot of experiments where we did not think it will work, or at least there were enough people who thought it did not work, but we came back and everybody agreed to trust the numbers. And you have to build that culture in your team where your team must trust it and actually talk about that, and talk only about that. It's actually hard. It feels like, it's just there's data, we should always, but it's really, you really have to build a culture where every small decision, bug fixes to this. We actually ask that question, when somebody has an ask for us, okay, which KPI are you going to move? And by how much? And those are much more objective conversations than trying to have a subjective discussions about. We've even had UX. When you build UX has lots of opinions. Should the button be blue or pink or something like that? Apparently, people click more on green. I just realized, because my CSAT response, the star rating is more popular on Xbox than on Windows, which is blue. So if you have, and a lot of times somebody will come and say, hey, I don't think that's a good UX. The button should be somewhere else. Okay, let the data tell you which one's better. I mean, I'm not agreeing or disagreeing with you. Okay, I'm going to take a little bit of time because this is, business decisions in AI. This is kind of a slightly deep or specific topic about AI and ML. I'm going to take it with a simple example. Face ID, everybody uses it for security. With your, my laptop has it, phones have it, lots of places, right? So you can have a really high threshold, blocks all imposters, like anybody else trying to get into your system, but you also get denied quite often. Maybe on your bad hair day, or you didn't shave, or I woke up and I'm trying to see my first Instagram message, and in the morning it doesn't work because it's too strict. Low threshold, you never get denied, so it's a really nice experience, but it lets a few imposters in, right? Formally, in AI models or any experimentation models, whenever you have this type 1 and type 2, they're also called as type 1 and type 2 errors. They're formally called precision or recall, or specificity and sensitivity. And the reason I'm bringing this up is you will actually hear this, especially if you're working on an AI product with your data scientists, they're going to bring up that this is, this is what I'm getting. So it's good to actually know that. Again, the Microsoft logo, right? But I switched it this time. So this is, on this vertical axis is the predicted, like let's say you're trying to predict, yes or no, and this is actual. True positive means that yes, the person was identified. False positive is an imposter. False negative is when you get denied on your bad hair day, and true negative is an imposter getting denied. I could have done it the other way also. A lot of times fraud detection actually uses fraud as a positive case, but this one's easier to understand, right? So what is precision? Precision is true positives divided by the true positive plus the false positives. Roughly, it means of the predicted, this is all about relevancy of your, what's the measure of relevancy. Roughly, it says that how many relevant versus irrelevant results you got from the model. Recall is true positive divided by true positive and false negatives. This roughly tells you how many relevant results. So one says relevant versus irrelevant, the other says how many relevant results. Okay? So usually there's a trade-off, as I said, if you increase the threshold, and a lot of times you can't have both. You can't block all imposters, but also have you pass every time. Although some of these technologies are getting really, really good. So mainly it comes down to this: cost of irrelevant results versus cost of missing relevant results. So what is the cost in phase? The cost of irrelevant results is some imposter getting into your phone and like getting all your data and your bank account, things like that. Cost of missing relevant results is that you are so annoyed, you're like, I'm not using iPhone Face ID anymore. And that could be even bad because you are actually not using a good security feature that should technically make your product more secure. So roughly that's the trade-off. And you will see a curve like this where precision and recall, they kind of inversely proportional. They're also analyzed using ROC curves, and you might see this in some, and that's why I want to, you don't have to go into the mathematical details, there's a lot of there, but you'll see this sometimes. So the middle line basically says that if you did not have any prediction, coin toss, right? So let's say your Face ID, half the time it allowed you, half the time it denied you. That's your line, and this is the curve that your model's providing. Roughly speaking, the more area you have under the curve, the better the model. Which basically means that let's say if you have your curve going all the way here, you have 100% precision and 100% recall. So that's the best case. So typically when you see something like this and you have, let's say, 3 or 4 models and you see different curves, you can just tell by this which is a better model. There are ways to find optimal point, like where you go, simply based on where it maximizes the precision and recall. There are F-scores and other techniques, but it really is determined by the business requirements. Okay? And the reason I bring this up is we can have all of this data from our researchers and experts. Ultimately, PMs make that trade-off. Is it better to, and it will depend on the product, right? In this case, obviously, the cost of a security breach is really, really high versus somebody not, using it. Another example is your alarm in your house. If it goes too often, you stop trusting it. If it doesn't, so those are the trade-offs, and you can do research. You can actually experiment at different so we've done some stuff like that where we experiment to see where we get the maximum thing, and it's usually useful to have an actual cost associated with it in terms of dollars or other numbers, and you kind of minimize that. Generally speaking, once you come here, without improving the model, you cannot change recall, which means you cannot change the number of missing relevant results. Okay. So, however, precision can be improved through non-AI, non-ML methods. This is obvious. Two-factor authentication. You can have a second independent test. You know, if it's an interactive experience, you can have asked additional information from users. So I do, as I said, I do wildlife photography, and I often go out and take pictures of birds. I have no idea what those birds are. There's a really nice app called Merlin, which allows me to upload the picture, and it tries to do an image recognition of the bird. And most of the time, it can just figure it out, but if it cannot, it actually asks me additional, where did you take this, when did you take it? So those are information we can ask the user. Typically, it should be friction free, so if you can predict without asking the user more information, we should do that. But if it fails, we have some ways out. And as PMs, we try to find those creative ways of getting there. In my specific area, we're trying to replicate humans. One of the simple ways humans improve precision is by asking more questions. So we just ask a few additional questions. Did you mean this? Did you mean that? Could you give me some more information? So that's how we improve precision, because we have that additional information which the model doesn't. Okay, and the main reason I bring this up is, like, there are three things, right? You will see this, what they mean, but don't be paralyzed if somebody says we cannot improve. There are ways to improve stuff through more creative ways. All right, so so that's kind of the main product management and AI and those areas. I wanted to switch gears and be a little philosophical now, and the reason I call it social sciences is that for the first time we are getting into areas where technologies are getting quite close to what humans are, and there's conflict. It's doing stuff like talking. We talked about the Google thing. That was creepy, but maybe not creepy for everyone. If we get used to it, maybe it's not creepy. But we are getting into that where social sciences are important. And actually, I got more interested because I actually started reading about how to make better conversations in chat, and there are ways to have that conversation, especially bots, be more engaging, and it really goes into the heart of how humans actually interact with bots, and how what kind of phrases they like, what they don't like, things like that. So I bring up this question: how human should your product be? That Google one was creepy, and it entirely depends on your team. But I pose them as questions, so you guys can go back and think a little bit about it. I don't know the answers, and I think we're going to so many things are going to change. We're going to figure it out eventually. But for now, at least in my product, we make it very clear you're talking to a bot. We made that call. Apparently Google didn't, but I think it's a good question to ask. Should it have a personality? Obviously, our voice assistants, they all have personalities. I find it also weird they're all female. I don't know if it's market research which shows these companies that they should be female, but it's a very important question to ask. Is it right? And even if your data shows that's what it should be, is it the right thing to do? Okay. Which brings me to, and obviously, the socio-economic impact, like Uber self-driving cars, probably going to make a lot of drivers obsolete. Lot of other jobs, they're going to be automated. How does that work? But anyway, what I was talking about before, bias becomes very, very real in AI when you're building AI products. Starting from the user stories, like, I just talked about all your assistants being female. Is it the right thing? I actually don't know. It's a good question to ask. Bias in training data. So this one happens a lot. So natural language processing and NLU, NLP, all of these are trained using publicly available body of text, and the way they do it is there's an embedding vector which basically does analogies in about 130 dimensions, and all it's doing is man is to woman is king is to queen, right? So analogies, I'm simplifying it, but it does it at 300 odd dimensions. And there are different ones, 100 dimensions, 130, 300 dimensions. When you train using text, let's say English, that text, let's say Wikipedia and books and things like that, that goes back centuries. The machine starts to create associations which is biased. Now, the analogy I told you, man is to women, king is to queen, is fine. But it starts getting worrying when man is to women is doctor is to nurse. It starts getting really worrying. And there are ways to do that, but there is huge amounts of problem with that method of training, especially text, any kind of data, especially because so much data is needed to train. You source it publicly, so inherently bias that is there gets into your data and therefore in your models. And we've seen racist bots, we've seen all kinds of stuff. Those are examples exactly why this happens. And obviously ends up being having some bias in outcomes. So anyway, these are philosophical and tough questions. I think as we go build more and more of such products that we will have to answer, we'll have to think about very carefully. And I don't know the answer, and I leave you guys with this that, I think the awareness is a great first step, and then, because a lot of times we're not even aware, things like that. Thank you.